All right, today for geometry, we have section 4.6, right triangle congruence. Okay, so with that, we want to review a right triangle. Okay, so we have our right triangle here. We know that this is the right angle down there. And then we have two important things to know about it other than that. Opposite of the right triangle is our hypotenuse. Okay, that's always opposite of the right triangle, or the right angle, I guess. And then we also have two legs. So the two sides that connect to make your right angle are both called legs of your right triangle. Um, and then over here we have that right triangle congruence theorems are special cases of the previous congruence theorems and postulates. Okay, so that's like the angle side angle, the side angle side, all of those are special cases. All right, so we have this diagram of these. So this first one is called LL congruence, which is a leg-leg. So we're going to go through each of these, but we have two legs that are congruent. So both legs are congruent on the corresponding triangles, or yes. Okay, and so that's a special case of side angle side, because notice we have a side, we have the right angle, and we have another side. The next one is the HA congruence, which is a hypotenuse angle congruence. So if we have a hypotenuse congruent to another hypotenuse, and an angle congruent to another corresponding angle, okay, that's the hypotenuse angle congruence, and it's a special case of angle, angle, side, because we have the right angle congruence, we have another acute angle, and then we have a side that is congruent. Then we have these two are both leg angle congruence. So we can have the shorter leg, okay, and the angle right that's connected to it, kind of the included angle. So then we would have, this is a special case of angle side angle congruence, because we have the right angle, the included side, and another angle. Okay, then with the other leg angle, we can have a leg congruent and the opposite angle congruent. And this is an example of angle, angle, side congruence, because we have an angle, the right angle, and a side that are all congruent. So it's a special case of angle, angle, side. So that's just so you can kind of see like, oh, we're just expanding on these, but there are specific rules if they are right triangles. Kind of like some shortcuts that we can take with those. All right, so let's move on down and start looking at each of these theorems individually. Okay, so that leg congruence theorem, or the LL theorem, if two legs of one right triangle are congruent, right, to the two legs of another right triangle, then the two triangles are congruent. So there's our then statement, right? So we have if and then. Whereas the hypotenuse angle congruence says if the hypotenuse and the acute angle of one right triangle are congruent to the hypotenuse and corresponding acute angle of another triangle, then the two triangles are congruent. So just kind of like what we walked through in the picture, we just don't have the picture here. And unfortunately, I couldn't put them all in the same space. Okay, then let's flip over, take a look at the back. All right, so on the back we have the actual theorems for the leg angle. Okay, so leg angle congruence theorem. So we have if a leg and an acute angle of one right triangle are congruent to the corresponding leg and acute angle of another right triangle, then the two triangles are congruent. And hypotenuse leg congruence. If the hypotenuse and the leg of one right triangle are congruent, okay, to the hypotenuse and corresponding leg of another right triangle, then the two triangles are congruent. Okay, and it is important that these are all right triangles. These are right triangle theorems, congruence theorems. They only work with right triangles because you already know one angle is a right angle, and those are already congruent. Okay, then this is a neat one. Proofs of many properties of isosceles triangles, okay, so we're talking isosceles triangles, depend upon dividing the triangle into two congruent triangles. Okay, so we can take an isosceles triangle, right, one that's equal here, and we can divide it into two congruent triangles. For a lot of proofs, we're going to do that. So the fact that congruent supplementary angles, I'm going to change colors here. The fact that congruent supplementary angles are right angles, that goes back to theorem 2.7.10, can be used to show that these are right triangles. Okay, because these would be right triangles because of right here. Each of these angles would be a right angle if we cut that isosceles in half. So that's going to be helpful for us a lot in this section and moving forward working with triangles, especially when it comes to isosceles triangles. Okay, so we're going to take isosceles triangles and cut them in half to do that. So let's actually look at a proof that's going to use that. It's an example 1. All right, so here's example 1. It says prove that a segment from the vertex of an isosceles, so we're talking about an isosceles triangle and we want the vertex, so that's B. So prove that a segment from the vertex of an isosceles triangle to the midpoint of its base, remember the base is down here at the bottom, and so the midpoint would be M, divides the triangle into two congruent right triangles. All right, so that's what they're giving us. That's what we're going to look at. So let's look at our given a little bit more and go from there. So we're given the isosceles triangle ABC with segment BA congruent to segment BC. So that's why these are marked. Okay, BA is congruent to BC, and M is the midpoint of AC. So M right there is the midpoint. We want to prove that triangle AMB and triangle CMB are congruent right triangles. That's what we're trying to get to, congruent right triangles. So we probably need to prove that they're congruent, and then we're going to have to prove that we have right angles in them. Okay, so let's look at our number 1 is what we're given, right? BA is congruent to BC, M is the midpoint of AC, segment AC. That was given to us. So moving on from there, got some help for you. Let's use that definition of a midpoint since it said M is the midpoint of AC. So let's use our given information and go from there. Well, since that's the case, the midpoint is the middle of AC, which means it cuts AC in half. So AM is congruent to CM, right? Because the midpoint cut it in half. So segment AM is congruent to segment CM. Okay, now the next one says the reflexive property of congruence. Where can we apply the reflexive property? Excellent. Okay, it's right here in the side that they share. Okay, that BM is congruent to BM. It's that shared side. So BM is congruent to segment BM. Is that reflexive property? All right, so 4 I don't give you any help on. What can you prove now that you know that we've got one side congruent to another side, right? So the hypotenuses are congruent. These two sides are congruent, and this last side is congruent. Well, we have 3 sides are congruent, which means we can say the triangles are congruent, right? According to the side, side, side congruence. We can say that triangle AMB is congruent to triangle CMB. All right, so here, if we go back to what we're supposed to be given or proving, I just proved that they're congruent. Now I've got to focus in on the fact that they're right triangles. Okay, step 5 is we're using that CPCTC. Corresponding parts of congruent triangles are congruent. Okay, well, what do we want to prove is congruent? What parts of the triangle do we want to prove that are congruent? Well, if we're trying to prove that it's a right triangle, we want to prove that the right angles are congruent. So we want to prove that angle 1 is congruent to angle 2. That's what we want to, like, we've already proved it, that they're congruent, but now we want to actually state it. So because angle 1 is congruent to angle 2 because corresponding parts of congruent triangles are congruent. Well, next we can use this linear pair theorem to help us. What does the linear pair theorem say? Okay, so good. The linear pair theorem says two angles that form a line. So it doesn't matter what two angles. But in this case, we have angle 1 and angle 2. But any two angles that form a line are supplementary. So we're going to say angle 1 and angle 2 are supplementary. So angle 1 and angle 2 are supplementary. All right, well, next up, we have congruent supplementary angles are right angles. Okay, I don't remember if that's a postulate or a theorem, to be honest, but I do know that it's there. So that's it. Congruent supplementary angles, which we proved 1 and 2 were congruent, right? So we proved that they were congruent. And we proved that they're supplementary. So now we can say, hey, that means that they're right triangles or right angles. Sweet. So angle 1 and angle 2 are right angles. That's an S inside my angle sign. Okay, which means I can then say, using the definition of a right triangle, okay, the definition of a right triangle is any angle with a right angle. And we said, or any triangle, pardon me, the definition of a right triangle is any triangle with a right angle. So not only are these congruent, but they're right angles, which makes them triangle AMB and triangle CMB congruent, which we proved in step 4, and that's why that says and step 4 over here. So triangle AMB and triangle CMB are congruent, which is what we were going for, right triangles. So we just proved that they were right triangles here. So they're congruent right triangles. I'm going to write over my handwriting. And so we just proved both of those things. So it's kind of like we did two proofs in one right there. And I think you might have a proof like this in your homework tonight even. I don't remember for sure though. All right, so there is that. So again, some special theorems just for right triangles, but you can also end up applying them in isosceles triangles because you cut the isosceles triangle from the vertex to the midpoint, okay? And we're going to have that. So good luck with your homework tonight, and we'll see you tomorrow.